Hey everyone, welcome to Tutoring. I hope you are having a great day. Today we will be going through a question, so question 12 from chapter 1E, which is the composite function topic of your textbook. So this is the last question of the topic, and a lot of students tend to struggle with this question. So without further ado, let's get into the video. Alright, question 12, let's have a read. Let a be a positive number, so we're starting off with a variable here, and let the function f with a domain of 2 to infinity have the equation a minus x, okay? And let the function g with a domain of negative infinity to 1 have the equation x squared plus a. Again, a is consistent here. It's everywhere in the equation for both of them. And then the question is, find all values of a, of course, for which both FOGs, so G within F, and GOF, F within G, exist. Right, so essentially what the question is asking is, determine what the values of A should be for these two functions such that both composite functions exist, okay? Right, and to answer this question, as I described in the topic video previously on composite function, and you might want to check it out, I'll leave a link on the pop-up above if you want to check it out. But in this case, I assume you've already watched the topic video, so we'll jump straight into the question. Right, so whenever you're doing a composite function question, your first step is to always draw a composite table. So I'm going to start drawing them here. So we've got two functions, f and g, and then we've got their domain, and then we've also got their range. Okay, so I'm going to draw this table. Just give me a moment right there. And we're going to split it into 4 cells. So we've got the domain of f, and then we've got the range of f, then we've got the domain of g, and we've got the range of g in this last cell right here. So let's go and proceed to fill in the details. So what is the domain of f? Well, let's have a look. My f, this is the function f, has a domain of 2 to infinity. So we've been given that information. Same thing with g, you can already find out over here. It is between negative infinity to 1. So I'm going to start filling that in, negative infinity to 1 inclusive. And then, of course, we now need to fill in the range. So how do you fill in the range of a function? Well, the best place to do it, or the best way to do it, is to sketch a graph. Okay, so let's look at function fx. Right, so we're going to sketch a graph. Fx, this is our axis right here, y-axis and x. You just have to do a rough sketch. You don't get marked on sketching a graph. This is just working out on the side. And the function fx has the equation a minus x. So the first thing we realize is 1, it is a linear function, and 2, it has been shifted up by the value of a. So a linear function typically would look like this right here, but it's been shifted up. And the reason why it's shifted up is because a is a positive number, okay? So if a is a positive number, so let's say it's number 2, then it gets shifted up by 2. If a was 3, then it gets shifted up by 3, okay? So in this case, I'm just going to put an arbitrary value of a and just move the graph up like this. And a obviously is the intersection. So we don't know what a is. All we know is the graph is a linear line that's being moved up slightly. Okay, and that has the function fx equals to a minus x. Now, you can already kind of have a feel of what the range is, okay? So let's have a look. My domain is from 2 to infinity. Where is 2? Well, I'm not sure where 2 is, but it's somewhere on the right-hand side, right? So you can already exclude anything on the left-hand side. So that's gone. We only want from 2, positive 2, to infinity. So going that way, to the right. So going to the right, we can already see that this graph is just going to keep going on forever. So it's the range, so your y value is going to keep decreasing all the way to, well, whatever, to negative infinity in this case. So you can start filling in your details. My range here is negative infinity because that's the lowest value. It can go all the way to negative infinity, but where can it go up to? So it has to stop somewhere, right? So if 2 was, for example, here, then what is that value? Well, let's say the x value is 2, right? Because my domain says I go from 2 to infinity. I've already gone to infinity, so where's 2? Well, 2, if you want to find the y value of 2, all you need to do is sub in over here. So let x equals to 2. So in that case, my y value would be a minus 2. So this point where it stops would be a minus 2, wherever that is. Maybe it's at the bottom, wherever it's at the top. Doesn't matter, we're just going to give it an arbitrary value of a minus 2. So in this case, your highest point, because your graph is a linear line, is a minus 2. It can't go any higher than this, right? So then you cross that out, and therefore your range is your range is negative infinity to a minus 2. And that's it. You've got your range. And now we also want to find the range of g. So let's draw that graph as well. Going to draw my axes again, right here. Y and x. Let's have a look. What is my graph of g? Well, it's x squared plus a. So if you're familiar with your parabolas, you would know this is just a normal parabola. So x squared looks like this. But again, it's been shifted up by a value of a. A is a positive number, so we know it got shifted up, okay? So your parabola, again, similar to what we did with the linear line, we're just going to draw it so that it moves up the axis somewhere. But the turning point is still at x equals to 0, okay? So that's important. So this is your parabola, and I'm going to give that the function gx equals to x squared plus a, okay? So that's what we know about this graph. Right, so let's have a look at the domain and start to, find the range of the graph. The domain is negative infinity to 1. So negative infinity starts from here, goes all the way up until 1. Wherever 1 is, I'm going to cut it there, and we stop using any part of this parabola that's after 1, okay? It is inclusive, so we'll put a dot there, and that we will call 1. Right, so now let's start looking at the range, okay? So where is the range? Well, I know my parabola goes up forever, right? So wherever you're going from the left or going from the right, your parabola goes up to infinity. So we know the highest point here, or the range, should be infinity, because it goes up forever. But then where is the lowest point? So if you keep looking at your parabola, you'll see that the lowest point isn't at the point 1, so it's not the end point like what we did with linear. It's actually over here at the turning point. And what is the turning point? Well, we know the turning point is at x equals to 0, and the y value in this case is actually how much the graph shifted by. So that is actually a. If you want to test it, you can sub in. So if you look over here, you can sub in 0. So 0 squared is 0 plus a is a. So the value at this point is a. So the lowest point of the parabola is actually at the turning point, which is a. So that means it is a to infinity, and we include a because that part of the graph is included as part of the domain. So now that we've got our domain and range for both functions, we can now easily apply the golden rule to determine for what values of a would make these two composite functions exist. So let's apply the golden rule. Now, recall this with me. What is the golden rule for composite function? Golden rule, I would state it again over here, is the range of the inside function, okay? The range of the inside must be a subset, so it must be smaller or equals to the domain of the outside function, okay? So that's the golden rule for composite function. So let's look at our first one, FOG. Okay, so this one is G is the inside, F is the outside, so G within F. So let's have a look. What is my range? Okay, what's my range? So the range of G, because range of the inside, range of G, you go look at your composite table and find that, it's over here, a to infinity. So I'm going to write that down, a to infinity, okay? And then now we question, is that a subset of the domain of F, domain of outside? So in this case, domain of outside, F here is 2 to infinity, and you're on the right track when you see that the numbers are quite similar, right? You've got a and 2 on the left, and then you've got infinity on the right, and you're thinking, oh, that's probably a good thing, it's a good sign. So we're not going to stop there, we're going to keep going, okay? So second one, we've got GOF. So GOF, so that is F is the inside, the function within the outside, which is G in this case. And let's have a look again. What is my range of F? Range of inside, range of F is negative infinity to a minus 2. And apologies, this should be inclusive, so I'll put that as inclusive right there, because a minus 2 will include this point, and that is a subset of domain of the outside, right? So G, what is domain of G? Well, again, negative infinity to 1. And there we go. Now, we've got our two sets of equations here, in a sense, or two sets of rules, where we can now try to find what the value of A is, right? Okay, so if you want the composite function to exist for, let's have a look at fog, F-O-G, then A has to be smaller or equals to number 2, right? So from rule number 1, so that's rule number 1, rule number 2. Rule number 1. Okay, so what values can A be so that this composite function exists? Well, if you have a look, A has to be bigger or equals to 2. Because if A is equal to 2, then this fits exactly. If A is bigger than 2, then this function right here, so let's say, maybe A is 3 to infinity, for example, then that function would fit inside the 2 to infinity. Because on a number line, you can have a look. This is 2 all the way to infinity. Anything after 2, you'll be smaller than that, okay? So if that makes sense, then A here has to be bigger or equals to 2. Very simple. I'm gonna erase this so that it's easy for you, it's clear. And then now let's look at number 2. Right, so for number 2, we've got negative infinity, that's fine, they match, don't have to change anything. And then we've got A minus 2 here has to be a subset of 1. So what that means is A minus 2 has to be smaller or equals to 1. Right? Because we want this value to be smaller or equals to, within this number set. So A minus 2, smaller or equals to 1, and you'll see that A has to be smaller or equals to, we move 2 over here, inequalities, A smaller equals to 3. Right, so again, we've got two rules. A bigger or equals to 2, and then for the second rule, we've got A smaller equals to 3. So therefore, what is your conclusion? Well, rule number 1 says that A has to be bigger than 2, so 2 to infinity. And then rule number 2 says A has to be small equals to 3, so that means negative infinity to 3. And if you want to find the values of A for which both rules would work, or both composite function would work, well, we just have to find the intersection. So right here, so you can see it right there, that's the intersection. So that means for any values between 2 and 3, for A, then your composite function here would work. So that means the graph or the composite function FOG and GOF would exist if your values for A are between 2 and 3, inclusive, okay? Guys, that is how you answer question 12. This is basically the ultimate question for composite function, testing you on your composite tables, testing you on your golden rules, and how to apply it, and also, at the side, sketching some graphs as well. So guys, this is it for question 12. I really hope you understand the concept of composite function and that you can apply it now to more questions or to your exam or your test. And that's about it. If you have any other questions, please leave a comment in the comment section below and I'll try and get to it. Otherwise, please leave a like, subscribe, and I'll see you in the next video. Thanks for watching.